Show that the formula for the sum of a geometric series is given by Sn equals a times 1 minus r to the n over 1 minus r. From this, show also that the sum of an infinite geometric series, where the absolute value of r is less than 1, is given by S infinity equals a over 1 minus r. First, consider the following geometric series in terms of a and r. Sn equals a plus ar squared all the way up to ar to the n minus 1. Note that each time we get another term, we're multiplying by r. We'll call this equation 1. If we multiply both sides of equation 1 by r, we get r times s to the n on the left side, and each term on the right side is multiplied by r, giving our first term of a times r, and the last term ar to the n. We'll call this equation 2. We can then subtract equation 2 from equation 1. Note that when we do this, we get a lot of canceling taking place. On the left side, we get Sn minus Rsn. On the right side, the ARs cancel. AR squared cancels. Everything cancels all the way up to a times r to the n minus 1. All that we have left then on the right side is a minus ar to the n. On the left side of this equation, we can factor out Sn, giving Sn times 1 minus r. On the right side of the equation, we can factor out a, giving a times 1 minus r to the n. Then to solve for Sn, we simply divide both sides by 1 minus r. 1 minus r cancels out on the left side. This results in Sn equals a times 1 minus r to the n over 1 minus r. For an infinite geometric series, as long as r is between -1 and +1, that means that the absolute value of r is less than 1. As the value of n gets infinitely large, the value of r to the n gets infinitely close to 0. As an example, consider 0.5 raised to the 20. This is equal to 0.000000953. So as n gets infinitely large, r to the n gets infinitely close to 0. As this happens, 1 minus r to the n becomes 1 minus 0. So it gets infinitely close to 1. We can then substitute 1 minus r to the n as being 1. This means that the infinite sum is simply going to be a over 1 minus r.